class name or the naming of a function or something like that. I believe that every project, every open source project needs such a person. And when it comes to coreboot, our next speaker is this person. Please give an applause for Paul Menzel.
Thank you very much to express most of what I do in such a nice way. Yeah, and it puts a smile on people's faces. Yeah, today I want to talk about ARM Chromebooks, something like this, what I have in my hand right here. And first of all, I want to thank also Philip for doing a great job to see so many people here at the conference, and also for all the other supporters, and Justine, who got a place for me at the hotel, which is very nice. So, and I'm looking forward to the next days. Okay, so who am I? Pretty quickly, I studied math in Berlin. I love free software because I think it's the only way to do programs and to use programs, to have all these freedoms. I'm active in Coreboot since 2005, which means I joined the mailing list back then and helped out at the Linux talk in Berlin and so on. And yeah. And today, what I do at work is at the Max Planck Institute for Molecular Genetics in Berlin, and yeah, more or less I'm a system architect or system administrator. We have a huge cluster, and yeah, someday I hope we also run it only with free software. Yeah, so let's come to Google Chromebooks. There are different architectures available. It's mostly, I guess, x86, then ARM and its devices, where I guess x86 is the most popular stuff, ARM second popular. I don't know, you have to talk to the Google guys sitting here in the first row. In x86, hopefully this will change soon. We only have Intel-based devices currently for which you can purchase. But there are several blobs included. That's first the blob Intel Firmware Support package, which does a lot of platform initialization, like initializing the RAM. Then there's also a coprocessor in the chipset, which is known as the famous Intel Management Engine. And then there's also yeah, microcontroller updates. And even though a big advantage is a good graphics driver in the Linux kernel, in newer chipsets it also requires blobs, which you can see in the Linux firmware repository. So I think starting with Skylake, they started to depend on firmware too. But another good advantage on x86 and Intel is also, like Linus once said when talking about architectures, it's really a big ecosystem because a lot of people use x86, which is also more or less viewable or present in the corporate community. I think all free-time developers, most of them also depend on or use x86 stuff or do x86 stuff. And regarding Chromebooks, there's also another good ecosystem. There are two people, Matt, I think, Mr. Chromebooks and John, and they build custom images for x86 Chromebooks and do it quite well, and there are images for media centers and so on. And then there's also alternatives to the Chrome OS system shipped on Chrome OS devices, which is Gallium OS, for example. But if you look on their webpage, it's also just supporting x86 devices. Yeah, so what's the state on ARM in general? So first, a small notice. I'm kind of just a user, so a lot of the stuff could be wrong, so if there is, please correct me, and then there are probably experts here who know the answer. So in ARM, there is, as far as I understood, a small, very small program fused into the chipset, which is known as the boot ROM. And this normally cannot be changed, but it can be analyzed, and as far as I understood, the sources are also freely available, so you can kind of also compare if what's in there matches what's it's supposed to do. In certain ways, it's as far as I understood, compared to x86, less legacy and therefore easier to set up. There's at least no management engine. There are also other alternatives like eBoot and Verbox, for example. The real bad thing on ARM is on the user space side that there's actually, for a lot of chipsets, no good graphics driver. You mostly depend on ROMs, and that also limits you in certain kinds of choices which kernel you want to use and so on. There are some projects or some devices where people went into reverse engineering and actually created a really good alternative, but of course it's always hard because if you don't have vendor support, because if the vendor decides to put in some other locking mechanism which prevents you from reverse engineering it, you're kind of stuck. Then in coreboot, there's more or less also the payloads which are provided. I think a few of them, only a few of them work actually on ARM devices. Most are tested with x86, and and the ecosystem I mentioned before, at least I didn't find a huge community who builds and provides images or operating system for ARM, tailored for ARM Chrome OS devices. Yeah, so let's talk a little bit about ARM Chromebooks. So the latest one, which is actually the one I preferred to show here, is the Samsung Chromebook Plus. It's based on the Rockchip RK3399 chipset, and as far as I understood the information, the boot firmware is actually quite, it's all free. And the downside is that it's only available in the USA. And yeah, so, and another downside is the used graphics device. It's a Mali device, and that's unfortunately one of the devices where a free driver has not yet been created. Yeah, so, and you also need blocks at the operating system level for the Wi-Fi and Bluetooth and hardware video decoding. And but it's probably not as bad, at least for Wi-Fi and Bluetooth, because I think the operating system makes sure through some techniques that if there would be a bad driver, that it can overtake other systems, subsystems. Okay, now let's come to the Acer Chromebook R 13. I don't know if you've seen it. I actually think it's a pretty nice device for the price. So at the bottom, it's like only €380, and it's available in Germany, and it's actually quite nice with a nice metal case and also touch screen and a convertible device. I actually think it's also of good quality, so I like it for the price. So good job, Acer. So while I showed you this, you could also see like the specification, what kind of MediaTek chipset is in there. It has 4 gigabytes of RAM. As all Chromebooks, the hard drive, it's not as big as you know from other consumer notebooks, but 32 gigabytes is also quite nice. Battery life is quite long. Display is also good, but as you see, as a graphics device, it's a Power VR, and that's also the second vendor, which is not where no free driver is available. Yeah, so just a quick status, because it's about where firmware blocks are used and where not. So as in all Chrome OS devices, the embedded controller runs Chrome EC, which is free software. And where on this device there is firmware shipped is on the PCM. It's probably Power Controller Manager or something similar like this. Maybe the controller for the USB-C device has firmware which needs which needs to be checked. And looking through the sources, there's also one display converter device which where I haven't found the firmware sources yet, but it can also be I haven't looked long enough yet. Yeah, on Linux the same problem for graphics, Wi-Fi and Bluetooth. You need firmware blobs. Okay, let's go. For those who don't know coreboot and ARM yet so much, I'd like to show a little bit how it's organized. So, because it's also a beginner's talk, didn't work. Sorry. Okay. So in coreboot, the tree is organized. You have like the source directory where you find the sources, and there you have the mainboard directory, and there it's organized by vendors. And in this case, it's Google board because Google kind of participates a lot or writes the reference codes for all these Chromebooks. I don't know how much the vendors adapted, but as far as I understand, they also have to give it back to Google, and the images are built from the Google repository. Yeah, and in there, in our case, we have the O mainboard, and that's kind of the reference design for the Chromebook I have here. And if you look at the kconfig name file, you see that there are kind of so-called variants. Yeah, so I think since 1 or 2 years, the structure has established that similar boards can be put together, and that's called variants. And in these config.name files, you put like the names, which you then also can choose in the kconfig menu. Okay, let's try. Okay, so in this case, the variant's name is Google ARM for the device I have here. Okay, so for those who have never built coreboot yet, there's a quick instructions. So first you need to create a cross toolchain where the CPU number is the one you have available. Then you configure it. Then you choose in the mainboard submenu the Google ARM device. Then to use the depth charge payload, you need to enable Chrome OS, which is under the chipset, and then you can select the depth charge device too. Then you run make. You can also do it in parallel on some devices. I think there are some race conditions at a certain amount, so which could be fixed, but make itself on one thread also works fast enough. And then you copy the created ROM under the build directory, which is named coreboot.rom, to the Chromebook, and preferably when you are in developer mode, you have to deactivate the write protection, and if you are in developer mode, the flash ROM tool is shipped on the Chrome device and you can just flash it on the device. Then there's an alternative way to build it, written by Paul. Is he here already? Yeah. Thank you for this. It's basically just a wrapper also, which more or less does the same automatically and ships configuration, tested configurations too. And the other thing is Paul has also put some patches in there, I think, which are not yet upstream, but he is also doing a great job upstreaming them. So if all these patches are upstream, then it shouldn't be any problem to also use the the coreboot build system. So, and Paul has a talk later about reverse engineering the firmware in this device, the PCM firmware, and I'm looking forward to it. So in board status, who doesn't know this, we try to collect the so-called status of the board, like certain kind of logs in the repository. As you can see in the very bottom, the album hasn't been uploaded yet. I tried to do it over the conference, but it's only because I had some patches in there, so it wouldn't be reproducible. So then a little longer versions for those who don't know the Chrome OS devices. There's a so-called developer mode, which you enable with a certain key combination. You turn it off and then you press, I think, escape. So F1, F4, and the third one, I think, or these two and the power button, and then you get into a menu where you can choose to start the developer mode with Ctrl D, and the security concept of Chromebooks actually then allows you to do it, but to be safe, it also deletes all data on the device, so it cannot be hijacked, and your data is more or less safe then, which is, I think, a really cool concept. And if you are in this developer mode, you have the Chrome shell, and which runs in a browser, and if you're in developer mode, there's a commando shell, which starts a normal GNU bash, and you have a lot of tools in there already, which are shipped by default, like flash ROM, CBSF tool, and CBMem to look at the logs in memory, which is kind of cool, and I think the Google developers did a really good job there. Also, the security concept in Chrome devices is certain parts of the flash chip are read-only, so write protected, and this is done by a screw. And the idea is you still have full control over your system if you open it up and remove the screw, which is, I think, this one. And if you open it, one downside of these very compact devices is it's kind of hard to open it up. You have to get into the hole there, and then you have to use some special device without damaging the Chromebook, but there are tools for that, and in the end it was quite easy. And if you use a screw, then you actually own the device, and you can overwrite the flash chip. And compared to other vendors, I think that's a really well thought out security concept. Okay, now a quick look at the shift image. So you can just read the ROM with the flash ROM if you're in developer mode, and then you can use CBFS tool to look at the ROM, and you see in current Chrome OS devices, they use the so-called flash map, and you have certain sections in the image, and each image can hold, for example, coreboot file system, yeah, CBFS. And this is the coreboot file system of the shipped ROM. And yeah, here you quickly see the well-known 4-deck ROM stage, RAM stage, verse stage. ER31, I think, belongs to the ARM trusted firmware. You have the configuration file which was built, which you can use to build the image which you can extract, and yeah, also the revision. Then for, I think, depth charge and the menus in the firmware, you have also localized messages. I don't know how other BIOS on firmware vendors do it, if the UEFI menu currently can be customized to the language. I don't know, but if it can't, this shows also how good a user experience it can be to ship messages in the language the user actually talks and understands. Yeah, then there's even more. There's a payload, which is, as far as I know, depth charge, and yeah, the device tree from U-boot. I still have to find out what this is used for. But yeah, so some more stuff for the components of a boot process for the Chrome OS device. There are certain parts. The verified boot concept for Chrome OS and the ARM trusted firmware. So if you want to know more about verified boot, there's a very good documentation written up by Lee. It's under the documentation Intel directory, but it's I think it's architecture agnostic, so it applies to all architectures. And yeah, just a quick summary. Verified boot requires 4 sections. This is the read-only section, then there's a Google binary blob area. You have firmware section, which is read and writable, readable and writable, the section A and the section B. And the idea is, because all the devices are updated over the fly, over the air, which is also kind of unique, you have to have a recovery path. And that's why the read-only section requires to have all the tools which you need to do a system recovery. And it's a well-tested system, so as you know it works, you can no, let's go back, sorry. As you know, it boots, you don't update it and just use it for... doesn't want to go back. Yeah, and yeah, some more information. So the read-only section also contains a key which can be used to verify the other sections, and yeah, it's read-only, and there's kind of a key chain. So each area contains then the next key, but it's signed with the key which is in the read-only section. And now come to ARM trusted firmware. As far as I understand, ARM devices require you to do some initialization before you even load firmware, and that's the ARM trusted firmware. It's a repository also on GitHub, so you can look at the sources. And yeah, ARM has some kind of interfaces and also yeah, features which you can enable with this, but we are already, it's BSD licensed, and yeah, I already talked about it, I think, in the beginning. So you have also these different stages, like this bootloader, the first AP boot ROM, which is fused on the chip, and then from there on you can also build and execute the next stages. And that's what you need ARM trusted firmware for. In this case, there are some blobs included in the C files. One advantage of beta reboot is they already collected this kind of stuff, and for example, for ARM trusted firmware, under configs you have this blobs file where you have the paths of the files listed containing firmware. So the first three influence are valid for the device I have here. The org one, it's not used in the device I'm talking about. Yeah, so there are three files where you saw it. So there's a system power manager, which needs firmware, and how it's done in these files, how the firmware is included is using these arrays. Yeah. So there are three files. So that's the hot plug, then some power management control, and here's the last one. Yeah, I'm now coming to the operating systems. So when you build your own firmware, which you can also build like with these verified stages, in the end you can still put the screw back in. If you use the depth charge payload, you can still use the Chrome OS device, operating system. But you can also build your own distribution, either overwriting the eMMC soldered device in the laptop, or using like just an eMMC card where you can boot from. And one note for this, you don't need to flash your own firmware to boot other operating systems. That's also possible with the shipped firmware, which is also quite nice, but you have to be in developer mode. Yeah, then currently on there's like an Arch Linux on there, but there's also, you can also run Debian on it, but I haven't tried the graphics acceleration under the user space yet, but there are instructions on the web how you can use the Chrome OS kernel, Chrome OS Linux kernel, for example, which includes all the drivers you need. Also, if you look at the slides then online, under some items, you have a link to the appropriate website, which with more instructions if you want to follow them and don't want to search for them yourself. Okay, yeah, just a note to Chrome OS. It ships Linux 3.18 on the device, which is quite old, but it works. And yeah, the Chrome OS, they have some requirements for the operating system and devices, and I think it's like to show the login screen at least in less than 10 seconds or 8 seconds. I don't know for sure, but there are these requirements, which is also quite nice. Yeah, right now, more to the payload on here, the depth charge payload. It's based on libpayload, the library which gives you certain infrastructure and methods which you know from tiny cursors, for example. And what I have to figure out is how to configure it, because right now if you start it, you get a screen which asks you where you want to boot from, but and there's like some kind of delay. So that's a default which differs from the shipped image. The FNet regions and the fallback, as said, for x86, there are already people who ship you images which also come with several regions where you can then also choose which image you want to boot. And yeah, but my goal is to copy the setup and to get a similar setup to also have kind of a fallback. So if you try certain new features, certain payloads, that you can use the firmware A or B section for this, and if it doesn't work, you still have the read-only coreboot section, which you can use to recover. I think that's a good development setup, or would be. So I'm a little ahead of my time, so
We have about 15 minutes of time for questions now.
you know.
So how many miles are these blocks? I didn't quite keep on top of how many blocks there are right now.
On this device.
Yeah.
Okay. So as far as I know, how you counted the boot ROM, which is fused in there, I think that counts as a block. And then let me go back. The USB-C controller might have a block. Then there is the display converter. This name, which could run firmware, which I haven't found yet, and yeah, the PCM firmware, which is at least shipped as a block, and but Paul reverse engineered it. 1 second.
So actually the USB-C on this one is pretty much passive, so it's hardware only. But the ANX definitely has a firmware. It's stored on a separate SPI flash, so it's actually easy to dump it. And I think it's probably AT51. I'm not totally sure about that. I looked at it like sometime. 8051, so like the 8-bit, you know. Yeah. And also, one you didn't mention, that's on pretty much all Chromebooks and all devices, that's a webcam firmware. No one thinks about it, but yeah, there is actually a microcontroller there with, with the firmware. But otherwise, that's pretty much it. As far as I know. Oh, VPU as well, but I think you mentioned it in the general.
Yeah.
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 More questions? Going once? Going twice? Oh, yeah.
So in your command for building the tool chain, you've got the CPUs equals 160. Why?
It's a Power 8 machine, and with 2 Power 8 processors, which we have at work, and it has 160 threads. I just wanted to show off. So. Because even the Epic device from AMD, you only get 128, I think. So fair enough. Okay. But there's a problem on Power 8 with the firmware utility, which is shipped in vboot. It kind of checks the architecture, and Power is not part of it. And I actually don't know how much device architecture specific it is, because when I said it should just use x86, it still builds a firmware, so no idea.
I have a badge for that. Not
Yeah, it's in kconfig, I think. So.
Yeah, that one was assigned.
Yeah.
Okay, there's another question.
Might be a stupid question if you obstinate not to include the trusted Jason firmware block. Will it work or it won't boot?
I think that's a firmware for the PCM device, and I think it won't boot, at least no. Yeah. So there's no chance.
So one thing you need browser for also working on the CPU cores on the operating system market. That part should be in the open source code. But you need it for the market. It would be possible to do that. There's also enhanced those from some of the by itself, but then there would be different SoC to SoC, and so this is the way of expressing certain functionality. So that's the
Yeah, so sorry, in the ARM trusted firmware, it's also pulled in as this third-party repository. Yeah, and as I said, you can kind of see the source files in here, and most of them are BSD licensed. Yeah. Yes.
Any other questions?
Everyone in the room who's younger than 8051, raise your hand. We can date that to about 1976. You? Yeah. All right, I was just curious.
Okay, no more questions? Going once? Going twice? Okay, that's a wrap. Thank you, everybody. And there's another question.
Have you tried updating the embedded controller firmware?
As far as I know, at least Chrome EC, the firmware is built with, if you build coreboot. So, but I don't know if it's then also updated. So yeah, no, I have to check this. Good question. But Paul knows the answer.
Yeah, so if you remove the red protect screw, you can actually just build and flash the EC software as well.
Nice. Yeah, sorry, maybe I forgot also something. So maybe a summary. So I think these ARM devices are pretty usable, at least for commodity device, for a travel laptop. So you don't depend on Intel or x86 anymore. You have to decide for yourself which downsides weigh more for you. Like if you try to fiddle with the user space side to, for example, get a Chrome OS kernel running and so to get the full graphics performance if you use it to watch videos or something like this. So, and yeah, as Google decided, or the Chrome OS folks decided that you actually own this device if you lose the write protect screw, yeah, you can install every operating system you like to. Probably not Windows under ARM. I don't know. I haven't tried it, but yeah. So in short, I think at least companies, as you as individuals, should. There's no reason to not buy a laptop which doesn't run coreboot. Yeah.
Okay, any more questions? I will take a hard look this time. Okay, so really no more questions? Okay, thank you again. Have another round of applause for Paul.